Okay, hi everyone, and welcome to today's edition of the AWS Study Series. Um, my name is Emeka Dadima, and I'll be moderating today's event. So, for today's topic, we have policy as code using AWS config and service control policies and OPA, right? And joining me today to give us a good and sound breakdown of that topic, we have Diogo and Nico with us. So Diogo is a senior information security analyst at DG's LLC and an AWS community builder. She's also the founder of Expertdocs Lab, a platform dedicated to mentoring aspiring professionals in cybersecurity, DevOps, and cloud computing, helping them build practical and real world skills to achieve mastery in their career. Over the past 2 years, with over 2 years of experience in security operations and incident detection and response, as well as vulnerability management and cloud security, Diogo here has developed a strong experience in securing and managing modern technology environments. Through Expertdocs Lab, she has mentored more than 170 entry-level professionals and career switchers across multiple countries and continents, empowering them to launch and grow successful careers in technology. So, Diogo, we're happy to have you here with us. Yeah.
Thank you so much, Emeka. Thank you for having me. Can you hear me, please?
Oh, yeah, I can hear you loud and clear.
And can the audience see me, please?
Yeah, that I would love to confirm. Okay, yeah. So, please, if you can hear us, can you just type in the chat? No, and just say your name or where you are joining in from.
Okay.
Yes, I'm
I
only
need,
seeing
I,
Temi
I need,
Tope Ojo.
I need to confirm from. Okay. All right, Mr. Timothy, we can hear and see us. All right, let me share my screen.
All right.
Which of the screens do I have?
So while
Okay.
she's trying to do that, for some of us who are not so experienced, working with AWS policy as code conflict, right? So I'm personally used to just doing the default thing. So I'm also open to learn from what she has to share with us today. Right, so while she's talking to you guys, I'll also be taking down notes on my end. And just so you are aware, at the end of the session, we'll be having a fun quiz, and the winner gets something nice as well. So please make sure you're paying attention throughout our session. Please continue, Diogo.
All right, thank you, Emeka. Please, can you confirm you can see my screen? I can't see anything from
Oh,
this
from your
point
end.
on. Yeah, because
Okay.
I'm using full screen. So just confirm you can see my screen. And
I'm
then
not
at any
seeing your screen at the moment. Okay, yeah, I'm
oh,
seeing your screen now. Yeah, it's fine now.
all right. So at any moment you lose me or you stop seeing my screen or you stop hearing my voice, I'd love to I'd love you to let me know. Okay.
Yeah, all right.
All right, thank you so much. Okay, today we are going to talk about policy as code and from a non buzzword perspective, from what it means outside of the whole cybersecurity, outside of technical explanation. I'll just say that policy as code is a way that we do something in a way that makes the computer be the one to audit it. The definition is very clear. Policy as code is a practice of defining governance, security, compliance, and operational policies in machine learning readable code rather than relying on document checklists and manual reviews. So now, if you want to implement a policy or you have a checklist, you have something that your organization is working on, a rule, let's keep policy aside. A rule, you want to enforce a rule in a traditional setting, there could be two ways to do that. First is that your company can use word of mouth to say, okay, because we are trying to be compliant and follow security best practices, nobody should create or maybe create an AWS account and log in from the console. It is a rule. And at the point of creation, the company is going to follow that. After 1 week, 2 weeks, 3 weeks, 4 weeks, perhaps after 1 month, after 10 months, one or two persons may have left the company and one or two persons may have joined the company, and the rule has been passed down to them. Okay, in this company, we do not create this, we do not create that. Perhaps the person you're passing this rule on to may not really understand why, even though you might have explained to them why. And after a while, a rule that was initially followed to the later might start having lots of challenges with implementation because it was said by a word of mouth. Another way that companies do this is we all work in tech. We have collaboration tools. We have that of Microsoft. There is Confluence. There is ClickUp. There is Google Doc, and your company has lots of Jira tickets. They have their own written down documents or policies or ways that okay in this company for our infrastructure, we have Kubernetes, we have CI/CD tools, we have lots of application integration within the environment. We have the AWS, maybe multi-cloud using both Azure, GCP, or using infrastructure cloud technologies like Heroku, using what is it called, Vanta, using Vessel, Superbase, and all those good stuff, all those technological integration. We can have a document that says, okay, this is the rule. You do not keep API keys on developer's machine, or you do not commit a make a Git commit and check in credentials into the commit. It is written down as a rule, and over time the team looks at it and they go back again to start looking at, okay, we have 5 persons in the IT team, and because we have 5 persons, they start auditing what each of the members of the IT team had done regarding that rule. Okay, Mr. Okafor has been following the rule to the letter and has been doing so well, but Mr. Biodu, okay, yesterday he did commit a secret into Git, but today he didn't do that. All those levels, all those processes, all those rules, the following of those rules or the enforcement of those rules in a way that you don't need anything manual, you don't even need an individual, you don't need to even make the rule in an unconventional way in the first place. All you just need to do is you have your technology. This can apply to AWS, but because we're talking about AWS today, let me just be using AWS. You have AWS and you have lots of plugins into your AWS. You have CI/CD pipeline, you have your IAC solutions, you have your Ansible for configuration management. You have a lot of things. You have GitHub checking into Amplify or Lambda picking codes from your GitHub repositories and all those good stuff. And because you do not want a situation where, for instance, there had been a misconfiguration and it would take you like 3 months to notice that at some point in time 3 months ago there was a misconfiguration and no one knew about it, or you don't want to go around chasing people. Okay, do this, you should are supposed to be keeping this rule but you're not keeping it. To take out everything, you just instruct the computer or you just instruct the system to be the enforcer of the rule. So the system is going to be the gatekeeper. And because it is technology, it is not human, it is not biased by emotion, or it's just looking at, are you keeping the rule? And it is not going to ask you, okay, you didn't keep the rule. Okay, you can go in later, you keep the rule. No, what you are doing, did it keep the rule? Yes, no. If it kept the rule, go in. If it didn't keep the rule, it drops it. So it means that the policy as code just keeps a baseline, and then aside of that baseline, it keeps a barricade. Only configurations, only workloads, only resources that has kept the rule are allowed to go into the other side. So the reason why it is called code is because it is embedded, it is written, it is configured already. So anything aside of that configuration is a possible fault. And because it is a fault, it is not allowed. As simple as that. That is the policy and that is the code. Anything aside of that code declaration is outside of it. You can also borrow knowledge from infrastructure as code to put it inside policy as code. You can borrow detection as code. Just any way that it was a rule or an any way that governance, security, compliance rules are written in form of code. There are different kinds of policies, policy as code, or different approaches to as code. As code, I mean infrastructure as code, detection as code, policy as code, anything we are enforcing through code. There are different approaches to it, but the overall concept of both policy as code and everything that has to do with codifying anything is just put it the rule into the machine and let the machine do the work for you. If you're going to review, you're only going to review on the part of the rule itself, not on the part of what the users have done regarding the rule. So you're not looking at who kept the rule or not. You're only checking if the rule is working as intended, nothing else, nothing more. So in that way, it solves a lot of issues that we are going to have to look at in the next slide. So what are the key benefits of policy as code? Why are companies using it? Now, from a security point of view, it is very auditable. What do I mean by that? Most policy as code solutions, they are already a technology. So, like I said, if you have 5 persons working in your team, you would need to audit what they are doing individually. And it is reactive, which means that a lot of things may have gone wrong in that pipeline or in that workflow that you didn't know about until audit cycle. But when you have policy as code, you are only auditing the policy. So now, in the policy, depending on the solution or where you're applying the policy as code, in this session, we have AWS config, we have service control policy, and we have open policy agent. So these different kinds of policy as code solutions, they work or they work in different ways. But I'm going to use AWS config as an example before we even get to AWS config deep dive. So now, what the policy is going to help you do is that it is going to record everything that has happened after the policy has been applied. It's going to help you look at the timestamp. It's going to help you record who made a change, even the changes that had passed, who made them. So instead of going to this each of the resources to go and look at who made those changes, you go and look at it from the policies. In that way, you can see the trail of users and trail of configuration changes over time, trail of time that these activities happened, and then if there is need for you to review the policies, if you think it is too rigid that it is blocking a lot of things in the workflow, you can have that review done. But aside from that, it just helps you check, audit everything at the same time. And sorry about that. So the other
Sorry.
one is, yeah, thank you. It is repeatable. What it means is that the same policies can be enforced, it can be applied the same way on different resources. All you just need to do is check what works. And in that way, you can just reinforce that policies. Or if for instance, you're going to create, let me use policy as code in an infrastructure as code solution like Terraform to explain this. For instance, Terraform is an infrastructure as code. It means that if you need to apply a certain resource on your infrastructure, AWS for instance, and the same configuration or the same resource, you already had a code initially with Terraform. You don't need to write a new one. All you just need to do is to bring the code and reapply it. Just change if you're going to use a different AWS account. All you just need to do is make sure that it reflects the environment where it is going to go into. You do that. And if for any reason you need to bring it down, you can bring it down. If in the next second you need to take it up, you take it up again. You are not changing the code. So because the code had already been written, if you want to apply it on multiple accounts, for instance, now let me use AWS config to do this analogy. AWS config is region based. It means that if you have your workload in US East 1, EU West 1, US East 2, EU West 2, maybe AP South or AP North or whatever, you have 5 regions and you have lots of workloads in those 5 regions. With policy as code, you can take the code that you applied in US East 1, you can take the policies and you go and apply it in US is to take it to the other region, reapply, take it to the other region. So in that way, you are not trying to manually configure the compliance or the security or the rules of that region in another region. So just take what works in region 1 and reapply it in region 2. And aside from that, if you bring down the policy and you need to reuse them, you don't need to go to AWS and make all the configuration. You just take the policy, the code, and reapply it. So that way you are solving a lot of, you are taking or bypassing a lot of time constraints or reducing the time it will take you to actually get something done. Put the time in something else and just use one single code. The only change is, like I said, it's not like it is all the policies that you would apply hook, line, and sinker. They could be if you're applying in a different environment, and if you're applying out of AWS, for instance, you might need to specify the account so that it applies on the right account. But the whole permissions, the whole policy, the whole body inside of the document is going to be just one. And in that way, you can take it across all environments. So the other one is it across different environments. So if it works here, for instance, if you have a stack of AWS accounts under one single AWS organization and you want to apply or you want to apply any policy, even aside from using AWS config and SCP like we have in this session, you want to even try it for identity and access management, you can use that and you can test it on one account. And if it works, you can also apply it. And if you test it and it works, you can always use that test to know that okay, if it works on this test account, it can also work in the actual deployment. So if there is any need for you to make any changes, you can make any changes. If there is any need for you not to make any changes, you can just afford not to make any changes. So again, it is scalable. Like I gave us in the first example I gave us, when you have multiple teams coming in. For instance, if you made a rule and it is manually written or it was a word of mouth, if the organization is increasing, you would need to also start telling people, tell everybody that gets into the company, okay, this is what we do, or please go to our shared drive to go and look at the rules of the company. And if you grow from 10 to 100 in 1 to 5 years, you are going to have a lot of time getting everybody in the company to validate or implement the manually structured rules. But if you have policy as code, or you have enforced your governance from code, or apply permissions in your AWS account or in your company in general, you don't need to tutor people or train them or give them details of how they have to follow the rules. All they just need to do is they try to do their work, and the policy blocks them, they do it the right way. After all, policy is not going to block you if you're doing the right thing. The essence of the policy is to make sure that you are not impacting on security. So the policy is just going to point you towards the right direction of doing the right thing. If you have one person who is working on the account, I mean, I have an AWS account that I'm just working on alone. If in the nearest future I have 100 persons working on that account, the same policy that applies to me would also apply to them without me making any possible change. And the sum of the whole benefits of policy as code is manual governance. It eliminates it by all possible means. You want to govern your configurations, you want to govern your cloud environment, you want to govern the resources that you have in your cloud environment, you want to govern everything inside of your AWS accounts. Using policies, using permissions helps you to take out everything, make sure that everything is working as intended. So if you need to go through your quarterly audit or your annual audit, you are just going to audit based on the actual policy that was applied and not based on the users, which means that you're going to cut down on the time it would spend you to audit those users environment, users configuration, by just going to audit the actual configuration that's applied the policies that you have for your environment. So going on to the next slide, I think I have this is an analogy that I prepared for to explain policy as code approach better, so that we can best understand the the concept in a real setting before we do a little demo. So what it means is that, let's take for instance public S3 buckets. There is nowhere in the history of technology that public S3 bucket has been beneficial. There is no way. If you're going to have your static site deployed in S3, it is not even supposed to be public. You have to go through CloudFront and allow access to S3 buckets from CloudFront, not from the internet. So that is why I chose to use this particular scenario. So now let's bring it down to a company. Maybe let me use, I have a company called Expados, for instance. Let me use Expados. So if in Expados, our rule is that no public S3 buckets whatsoever. Like I said, if you are a front end engineer and you need to deploy any of the static sites, please do not, for whatever reason, do not create any public S3 buckets. Always make sure you go through CloudFront. So it is a rule, right? 100% checked. But I may not be there all the time to tell you what to do. And one bottleneck we have in cybersecurity in general is that security has lots, yeah, on its own has lots of bottleneck. So at some point in time, you just need to get the work done, and you say you come back to securing it later, and you may forget. We are humans, and we one thing about cybersecurity is that humans are one of the weakest links in cybersecurity, which means that if you have all your technology and the humans are not doing the right thing or following best practices, they are going to eventually expose or get your business into trouble. So that one aside, in the traditional approach, you're going to have your policy documents. Okay, this is our SOPs. This is how we operate. No S3 bucket, no public S3 bucket whatsoever is allowed. You have it written. And people who are joining the company, your IT team, your developers, they're going to go to where you have the documents published. They're going to have a read everything, and then they do what they want to do. At the end of the day, I have to still go back to the AWS account, start checking all the S3 buckets and all those good stuff. So with this approach, you are very much prone to human error, which means that if, for instance, the developer forgot, he's going to eventually allow an S3 bucket or make it public or not secure it enough. And inconsistency, everybody, there are different ways of doing a particular thing, like I said. So based on that, what developer A or what developer B or what the number one person or the number two person they do may be inconsistent. I'm not saying that the inconsistency is something that is 100% general, but approaches would always differ and there may be inconsistencies along the line. And based on this, you could have delays in execution of that. So that delay is in execution of the or application of the compliance or application of the security on the S3 bucket or S3 buckets approach of the company. And reactive enforcement, it means that if something had gone wrong, you are only going to find out after it has happened. It is not proactive in a way that it alerts you before it happens. It is just after it has happened, maybe months or days or weeks after it has happened, or even years after it has happened, that oh, you get to find that. And most probably the people who you are trying to protect against, which are the hackers, may even get to find out way before you do. So but with policy as code, you already have your policies. For instance, you use AWS config to define no S3 bucket policy allowed in the company whatsoever. Or you use service control policies, or you use S3 bucket policies, whichever ways. But then what happens is that that bucket will not be created in the first place if the policy as code has been applied. The developer is going to eventually get lots of errors in creating an S3 bucket. And you know how simple it is creating an S3 bucket. And this is where you get somebody saying, I've been trying to create an S3 bucket for like 2 years or 2 days now, and I've not been able to create it. It may be the policy that stop the developer, or not even it may be, it is the policy that will stop the developer from creating the S3 bucket that is public by default. So now, for so most policy as code, especially open policy agents, you can store them in your Git repository, which means that you can audit it, you can check or review the configurations, and it grows with your environment. And again, like I said, you can always test this policy, test it. If it works, you continue to apply it on different use cases or different accounts that you have tied into your main account, and it is automatic. Means that if an S3 bucket is being created to the public, it automatically denies it. You don't need to take permission from anybody, you don't need to call anybody, you don't need to let anybody know. Everything is denied or everything is allowed automatically. And this is when I said immediate feedback. So if we're going to eventually work with config and you see how fast config flags security issues, and then prevention instead of detection. Again, in cybersecurity, it's best that if your tools are not preventing you, they are only detecting, you may miss the mark. But if it prevents, you can be sleeping and just audit later, see what happened. But you may have stopped something wrong from going on in the first place, other than just detecting it and letting you know until you try to dig deep or investigate to find out. And continuous compliance. So long as the policy is applied in the environment, you are sure that people who are working in your environment are going to continuously comply. There is no two ways about that. They will always, always, always comply, whether they like it or not. And no matter how tough their job is, they will always work the right way and then reduce risk. That is the overall summary of security in general. If there is no risk, there won't be need to secure anything. There won't be need to comply. There won't be need to enforce. There won't be need for us to even have cybersecurity or have security in the first place. So that's reduced risk would also help you to ensure that, okay, at the end of the day, even though the introduction of technology in your business exposes you to certain kinds of risk, but having automatic policies that help you to ensure that people who are working in your environment, they are consistently complying, will help you to reduce your attack surface. So moving on to the next slide, I'm going to talk deeply into the three objects we have for today's session, which is the service control policy, and then we talk about AWS config and open policy agent before we do a little of hands-on. And now, what service control policy is that it is, how will I put it? It is the it is like the headquarters of, or let me use a bank for instance. You have the Central Bank of Nigeria, and you have lots of commercial banks. You have fintechs. You have which other cadre of banks do we have? You have microfinance banks. You have banks of industry. You have agri bank. All these banks that you have in the in the country, the answer to the central bank, it means that if central bank says do not, they don't. If central bank says do, they do. So that is what service control policy is. So what it does is that it helps you when you have hundreds of AWS accounts, not even hundreds. I think I don't know which company has over 100 AWS accounts, but let me just bring it down to something more realistic. Most big companies that you have there that are fully AWS, are fully native on AWS, they have a minimum of 5 accounts. And as time goes on, they could be creating more. What the service control policy does is to give you that policy that applies to accounts that is being created, or you have an AWS environment with lots of accounts, and in those accounts you have organizational units. So for instance, you have organizational unit 1, organizational unit 2, organizational unit 3. Inside of those OUs, you can have 3 to 4 AWS accounts tied into one OUs, and you need maybe organizational unit 1 to comply to a certain standard, or you need them to meet certain security requirements inside of them. So the service control policies helps you to apply that policy from the root AWS account, which is the management account, the foundational account that the company has. You can use it to apply certain policies on one organization unit, or you want to apply on all organizational units, it is fine and good. If you want to apply such policies on individual accounts, you can also do that. And if you want to apply it on all organizational units, you can also do that. So the service control policy is at the apex of an AWS organizational unit or AWS organization. So what it does is that, how it works is that, again, number one, it lives inside your AWS environment and acts as the permission ceiling. So what it means is that, if, let me use out of technology to explain this. So let me take for instance, I don't know what they call these people who do high jump. Maybe let me just call them people who do high jump. And if I do high jump and I can jump as high as 100 meters, that is my capacity to jump. But there is a ceiling. Maybe the ceiling is just like 10 meters ahead of me. No matter what, I can't jump above the ceiling. Even if I try to jump 100 meters high, the ceiling is going to, I'm going to eventually hit the wall on the ceiling, and I'll come back. That is what the organizational unit is. So when an AWS account is created and an organization is created out of that AWS account, you eventually have AWS full access as a permission that is tied to all the accounts that is created inside the AWS organization. But you use the the service control policies to deny some actions that you do not want those member accounts to perform on each of those accounts. So for instance, you know how, let me use the use case that I have on the screen here. You know how CloudTrail, what CloudTrail does, it is one of the most important security features on AWS, because it is the service that trails every activity that happens in the environment. And if an attacker tries to get in, or if someone wants to do something bad in the account, what they're going to do first is to stop the recording of CloudTrail. It means that if, for instance, I have gotten into the account and I have lots of things I want to do and I do not want to be seen, I will stop the trail on my account. That is the first thing an attacker is going to do, because from there you can get to know what he did, how he got in, what he did when he got in, how he was able to move from here to there, from here to there, and then how he went out. So I'm going to stop trailing. It happens with most, aside from CloudTrail, it happens in most systems. So if anybody tries to hack into a system, they stop the audit of that system so that they won't be found out. And why are people stopping CloudTrails? If you have a security solution or you have a dedicated security team and they have lots of visibility systems into your AWS account, once somebody gets into your AWS account and the person is not supposed to get in, CloudTrail would signal them. Once they start working, CloudTrail will signal, which means you can get caught before you have perpetrated what you got into the account to do. So people are going to eventually stop the trail when they get in. So with service control policies, you don't, if you have 10 accounts in within the AWS organization and maybe in account one somebody breaks into it, they can't stop the trail. That means in the service control, in the policy as code right now, you've enforced a policy on the account, on the organizational unit, on the AWS organization, that all the member accounts, nobody can stop training anything on the member account. So even if you try, it won't be possible that you can stop training. Or if you want to apply a service control policy that says, for instance, nobody should create, no IAM console users. So it means that for dev environments or for staging environments, you do not want people to log into the AWS console. That means you can't create console identities. You have to create identities that will have to log in from the CLI or have to log in from the SDK to be able to do whatever they have to do on the environment. You don't need to manually get the policy to be applied to create the policy document, apply it in account A. You use service control policies to apply it on all the accounts within that organizational unit, or all the accounts that you want to affect, or all the account that you want to apply those solutions or those policies onto. So it's like I said on the screen, it can help you apply guardrails on all the accounts. And again, it does not grant permissions. It means that when you get AWS full access, you get access, the member accounts get access to everything. You use the service control policies to deny what you do not want them to do. So as at that level, even if they go into those individual accounts to allow it, for instance, you're not allowing S3 bucket policy to be, you're not allowing S3 public S3 buckets in some member accounts, or you want to allow it for certain reasons. If the service control policy says deny, you can't allow it even though you are in that account and in the resource. So by that way, whatever the company, I think at that level, whatever the organization does not want for all the accounts that are members of the organization, AWS organization, they can use service control policies to apply each of those. So we are going to move on to the next one, which is the, for the want of time, AWS config. So AWS config, what it does is that it looks at all your resource configurations. So mostly, even the in the setting of the AWS config, you might want to look at the resources that have been created before you apply the config rule, or you want to look at the resources that are created, that will be created after you've applied the config rule. It all depends on you. And then you can use it to evaluate the policies against certain compliances. And AWS has a ton, I think about 100 plus managed config rules that you can apply to your account. But if, for instance, you AWS does not have a rule that you can apply. You can make your own custom rule, and you can use Lambda to get the rules to get triggered once there is a misconfiguration. And you can also apply manual remediation on the account and also apply automatic remediation. So the manual remediation means that, for instance, you have a public S3 bucket, AWS config finds it out and flags it. You can go to S3 buckets and remove all public access. And if you want to automatically remediate from AWS config on its own, you can get into AWS config and then apply a remediation. So it's going to, I think at this point, it's either going to make the S3 bucket private, or it is going to block the S3 bucket on its own. So these are some of the examples that of what you can do, or of different use cases. Like I said, there anything you want to apply with AWS config. If AWS config manage rule does not cover for it, you can always create your own custom rules to be able to make sure that everything that you have within your environment is compliant to the standards that you want it to comply. Then the last one is the open policy access or open policy agent. So it is mostly not AWS native, it is an open source solution, and it works in, you can use it for AWS, especially when you are working with infrastructure as code. You can plug into your Terraform and then plug it into your AWS code build for CI/CD. If you're using GitHub Actions, you can plug it, and then you can always use it to validate your plans, especially when you're using infrastructure as code. That is how it borders so much with the cloud. So open policy agents or open policy access, what it does is that, aside from cloud, you can use it across all infrastructure. Almost all the software solutions you have out there, you can apply it to them. But if you're going to be declaring infrastructure as code, or you're going to be using EKS, you're going to be using CI/CD on the cloud, you can now bring it to the cloud. And if you want, especially if you want to use Terraform or you want to use Ansible and you want to make sure that it is compliant to certain standard, you can now bring it in. And then it works with JSON, which means that Terraform is written in HCL. So it doesn't understand any language aside from JSON. So when you do your Terraform plan is going to, at the back end, is going to take your Terraform HCL file and it translates it into a JSON, so that the regular policy language can query the configuration that you have inside the Terraform document before you apply it onto AWS account. And if there is anything, if it flags anything, there is an automatic, it stops it automatically from being checked, or the resources from being created in your AWS account. So I think that is it. For the want of time, we're supposed to round this up. So this is just the summary of everything. So with the policy as code topic we have today, we have the AWS config, we have the service control policies, and we have the OPA. So what it does is that the AWS SCP sits at the organization level. Like I said, it is the headquarter rule or the headquarter policy that is applied for all accounts. So it means that as the permission ceiling, before any action is taken on that environment, or it's not even before any action, you can't even take an action that has been denied in the service control policy. You can't. Then with AWS config, it does not stop you from deploying. So if something is not explicitly denied in AWS service control policy, what would happen is that when you have the config is that you can now use config to track the ones that you could not deny. So if, for instance, you didn't deny S3 public access in the AWS service control policy and you have it in your config, now the service control policy denies you from creating, but it did not because there was no service control policy. And config is going to act after the resource exists. It means that you have to now create the S3 public S3 buckets with a public asset access. So it is after the resource has been created that AWS config is going to track it. It will not stop you from creating it, but it's going to track it when it is being created, after it has been created. Then the same thing with open policy access. It evaluates before it reaches. So before deployment, you can use it to deploy your resources on the infrastructure. And it's the same with, it's almost at the same level with SCP, but at a different kind of domain or applied in different kind of settings. So like I said here, most companies use it for defense in depth. You want to look at the what is going on inside the AWS account, and you also want to look at what would come into the AWS account from the infrastructure as code tools or from your automated deployments from the CI/CD or automated deployments from your infrastructure as code solutions. So that would be all. Then I think we just have a little time to get this demo done. I'm going to stop sharing my screen now. Okay, please let me know if you can still hear me, Emeka.
Yeah, can still hear you fine, audio or true.
All right, thank you so much. So I'm going to start. I'm just going to do something little for the want of time for the AWS config and then the AWS service control policy. And I have just a little thing here for the open policy agent. Open policy agent is a full-time job on its own. So we're just going to just see how it works on at a high level. Now, I'm going to start with AWS organizations, and because of the demo, I'm using the root account where I have service control policies currently working on to get this done. So now I have a few accounts. This is an organizational unit. I have two accounts here, and this is my management account. And if I want to apply a service control policy, it is simple. So I'm not going to write the code myself for the want of time. I already have everything written. So you just have to come down here. First is that it has to be enabled. And because I have a few service control policies enabled on this account, so I had earlier enabled it. So coming in, I think I have the code written down somewhere. Let me just look around for it. Okay, so now this is my CloudTrail service control policy that is applied. Now, this is the, when I said initially, when an AWS organization is created, AWS full access is granted to the account so that the account can be able to operate. So now I had this one done initially. This is what the policy is. So it is to stop the deletion of CloudTrail or stop CloudTrail from logging or anything that has to do with CloudTrail from the anomalous point of view. So in AWS CloudTrail, for instance, this is the API call: delete trail, stop logging, audit trail. This is the API call that's, if I do anything in CloudTrail, for instance, this is how CloudTrail is going to record the action. So what this policy does is just to deny, and then resources, all resources, everything on this account, deny deletion of trails, stopping logging, delete trails, and or whatever. So now I have already applied this on the root account. It means that every organizational unit on this account would have this rule applied to them. So if you want to, okay, let me not, there's no need to tag this one right now, but let me just go back so that we can create one and then attach. So for instance, let me create this rule and call it maybe, I don't know if I should go to AWS config first, because I have a config rule. I have a config rule in this service control policy document that I also need to apply, but let's start with this one first. We can just get it deleted and later we work on it. So for instance, let me give this policy a name. stop, deny, cloud trail, deny deletion. So this is where I'm going to apply the policy in this document. So let me I have to just give me a little time. Let me look for, yeah. Okay, this works. So let me take this. This code is going to nine. It's going to we already have CloudTrail rule applied to this SCP, the initial one, but for the want of the demo, let me just apply this rule. So what will happen is that it will deny stop logging, it will deny cloud trail, put anything that has to do with put event selectors, remove tags. So and then where the policy would apply is on all resources that this role or this policy is going to be applied on. So at this point in time, when we get this policy created, it is not working. It can't do anything. There is nothing that the rule is going to, or no account, or nowhere, or nobody is going to inherit this policy. So what we are going to do is we take the action and then we attach this policy to, this is an organizational unit. We can attach it to this organizational unit. So that means all the accounts that are inside of this organizational unit called workload, we inherit the policy. So what it means is that anybody within this account, or any all the accounts, or anybody that enters into any of the accounts that tries to perform any of this action, they would automatically it would automatically be rejected, or they would automatically be denied performance of that action. So there you can create with AWS service control policies, you can create as many policies as possible. This is not just all. If you have a lot going on, there is no limit to the number of policies you can create. And then if you do not want to apply service control policy, you can just disable it. But it is dangerous not to have service control policies applied, especially when there's an AWS organization within the account. So going to AWS config is a little like service control policy, but because no, let me let me just go to a different region first. So like I said, AWS config is regional. That is why I know that somebody might just say, okay, if there is AWS config, why use SCP? AWS config is regional, which means that if you have workloads in all these 17 regions, you need to apply each of the config rules in all the regions. But if you want to, and again, service control policies, there is you can use service control policies to do everything, but there are things that you need to use service control policies for. And then for flexibility, you can use AWS config, especially when all the accounts in the OU are not doing the same thing. So you can use config to make rules that apply to you, that are unique to each of those individual accounts. So I have this thing, this AWS config enabled on this. This is my region, but let me change it to Northern Virginia so that we can enable. I won't enable it. I might forget to disable it, and AWS config is expensive. So let me just show it for the one what it looks like before being enabled. So once you click on setup config, get started, any of them, one click setup, it would automatically enable, and you can't disable it. That's why I'm not going to allow another one to be enabled right now. So now back to this. I think I have a document written somewhere about what we are going to do. I think it's EC2 instance, right? Security group. Okay. So going to the dashboard. So now there are two ways to using AWS config. So first is the conformance pack. What it does is that it is like if you have 5 rules, if you want to have EC2 instance, for instance, EC2 instance has security group. It has a bunch of different things that rules that you might want to apply to the EC2 instance, and you do not want to create rule one for maybe security group, rule two for maybe SSH, rule three for something else. You can use conformance pack to get all the rules that apply that AWS has, or all AWS managed rules for EC2 instance under one configuration or under one policy. So it brings five policies together or 10 policies, depending on how many policies AWS or how many rules AWS has for the resource or the service that you want to use. But aside from that, for the want of this demo, let me just go to the rules first. When we apply the rules, we can come and try and look at the conformance pack and see what different approach or what we can do different with the conformance pack. So the rules are going to, like I said, AWS has lots of rules. At this point in time, there is no rule here. So what we are going to do is, first is that I have to enable this. I think this is not recording. So right now, this is, like I said, AWS config is not cheap. It is expensive. So now, two ways for not to be charged if you're going to try this in your AWS account is always to stop recording when you are not going to use the config. Even if you have rules set up, once it is recording, for every configuration that is made and everything it records, you're going to be charged for every record. And if you have 5 rules, you have 10 rules, you have 100 rules, you're going to be accumulating lots of money in the account from AWS config. So that was why I had to just turn this off. So let me get it turned on. And then we go back to the rules. So add rule. Now the demo says create security group and watch config flag it. So we're going to look for anything that has to do with security group. Now we are using AWS managed rules. So we're going to have to find rule for EC2. No, I think the name of the rule is restricted SSH. Hope my system is not hanging. Restrict. Restricted SSH. Okay. So now this is what the rule does. That's the name of the rule, restricted SSH, AWS EC2 security group rule. And it checks whether security groups that are in use disallow unrestricted incoming SSH traffic. That means is that every SSH traffic that is set to anybody on the internet 0.0.0.0.0, this is what this rule is going to flag. So the next thing is to apply it. Now when, oh, they've taken the lights, sorry guys, please let me know if you can still see my screen.
Yeah, I can still see your screen. I can still hear you clearly.
All right, so okay, so now this is the all resource group. So it means that when any changes, when any resource recorded and AWS config is created, changed, and deleted. So this other part that is automatically checked is when any resource that matches the specific type or the type plus identifier is created, changed, or deleted. So this is going to be our best selection for this demo. And how frequency, what is the frequency that you want to be notified? So you can have 24 hours, you have 1 hour, you have 3 hours, you have 6 hours, you have 12 hours. So, but then this does not mean that if you come after we've created this rule and we try to test it, when we come into this environment, we are still going to see that a rule was flagged. So now going into creation, so simple as that. And this saves the rule. So if we go back to the dashboard, Okay, so now before we go back to the dashboard, let's go back and create security group that would fault this rule. So let me type security group on the screen. Okay, I have one default security group rule created, and then let me create a new security group and make everything public. So test security group. Our traffic. So we are looking for SSH traffic to anybody on the internet. Okay, let me create this security group. Okay, so I think this has been created, and then one inbound, one outbound. Wait, that means we need to delete this. We need to edit this. I think it's not letting him, it's not allowing inbound rules. So we
Mm,
need to edit the inbound rules.
okay.
Okay, okay. So let's go back to AWS config and get this refreshed. Okay, hasn't cut it yet. So we'll just have to give it a little time for it to find the configuration we just made. And while we are working on that, I think I have to just look at the conformance pack. So let's try to see if we can deploy conformance pack. So what does this does, we're going to use this template and we are choosing best practice or best practice for EC2, for instance. So operational best practice for EC2. This is going to deploy all rules or configurations that has to do with EC2 instances. So maybe confirm best practice or EC2 best practice. All right, so now it has flagged one, and then under this is from conformance pack. It has also flagged one, and this is under the rule. It has also showed us that we have one non-compliant resources. So if you want to go deep, you can go to the rule or go to the rule from here. So it points you to the actual EC2 instance and gives you tells you the frameworks that it got flagged in. So these are all the frameworks, the PCI DSS and all the frameworks. And this is the last evaluations that, like I told us initially when I was explaining the AWS config thingy, that you will be able to record changes over time. So this was the last time that this policy was touched or something. So this is the trigger, was last 24 hours. This is the changes in the last 24 hours rather. So now it shows us that this security group is non-compliant. So in this way, like I said, it doesn't block you. It only helps you to flag the ones that are non-compliant. So if we go back to maybe remove all inbound access from maybe change it. Let me not even remove the inbound traffic. Let me change the inbound traffic from my personal IP address, for instance, and see if it's going to flag it in a different way. I don't have my IP address in my head. Let me just search for it. Okay, so going back to the rule, let me go to the dashboard. Restricted access service endpoint. So these very ones, I think this should change after a while, after maybe 2 minutes or so. The restricted SSH and the complementary rule from the conformance pack should change. But the reason why we are getting others flagged is that, let me go to the conformance pack itself. There are lots of rules that are inside it, like I said. So it would apply other rules. So in that way, I think with the conformance pack, in that way, things that you might possibly miss. Like I said, AWS has lots of rules, and under this conformance pack, only for EC2 best practice, we have 22 rules that are trying to help you protect EC2 instances. So it just covers everything. In that way, you don't have to create individual rules for EC2 instances, except out of all these rules here, that they don't fully solve or they don't fully address your peculiar security needs for your EC2 instance. You can now go and create customer managed policies or customer managed work. So let's back to one.
Do you go? We can't hear you anymore. Can't see your screen either. Okay, so let's wait a bit while she tries to join back in. Probably a network or something similar. Alright. So while we are waiting for her to join back in, right? So for those of us who may have joined the call late, or for those who may have skipped a few things while on the call, I'll just go over a couple of things that I've picked up myself while listening to our session. Right. So first off, topic that she's covering is policy as code using AWS config, service control policies, and OPAs. Right. Now at the start, she explained what policies as code are basically. So it's basically you setting up rules for your organization on AWS, things that you want to apply and things that you don't want to apply. Right? So for example, you could say that on my AWS account that I don't want anyone to be able to SSH into an EC2 instance. Now, on a normal day, you have to like ask people not to do that and start monitoring if or when they do that. And that is, that is not the best use of your time. But with policy as code, you can write those rules as code, right? You can have them committed on whether your GitHub or your GitLab, and AWS enforces those rules for you, right? So that is the first thing. And then she also, she explained how this synergy works. So you just said the rules how AWS enforces those rules. Okay, so the logo is back, right? So I'm gonna pause my summary, right? So yeah, I think you lost you for a second or for a minute or two, right?
Alright.
And so while she's still trying to come up, right? So I think one way I understood that question was you can see the policy writing as you being a lawmaker, right? Or you being a member of the German government in the legislature. So while AWS acts as the executive arm of government, right? Like they enforce those rules for you. So then with policy as code, right? You are more concerned with auditing the policies themselves, not your users' actions. Right. So you can let AWS handle auditing those actions while you just focus on okay, are these policies correct, right? Do they make sense? Does it apply the way it should apply and the rest of that? I do go just let me know when you're ready to go. Right.
Alright, trying to get my,
Screen up.
yeah. Sorry, I
Okay.
got kicked out. My PC that I have here is quite little and it's always fighting with restream.
Oh,
So
okay, yeah. No problem. Yeah, problem.
so okay.
Yeah. So I think she also mentioned that using policy as not using policy as code is a reactive approach, right? So for example, if you don't have PSA enabled, right, then you're probably the kind of person that you don't sleep at night because if something goes wrong by 2 a.m., you have to be able to fix it immediately. And but with policy as code, those actions will never be allowed in the first place. So you can wake up in the morning and see that those actions were denied or rejected by those policies that you set up correctly. And then she went a bit deeper into service control policies, and this basically they apply at the root of your organization. So once you enable some service control policies, it applies to as many accounts, as many resources that you have under that AWS account or AWS organization. So you can set some, I guess, a global level policy that that want to apply across all your departments or all your different groups of devs. Then she also talked about AWS config. So similar to service control policies, but in this case, it applies to AWS regions, right? Because obviously you might have some rules that you want to enable in certain regions that you don't want to enable in certain regions. So you can use AWS config for those edge cases, right? For those scenarios, so that it gives you that flexibility to say that okay, if I'm in the US, maybe the US has certain rules or restrictions about how they prefer things done. So you enable those policies for resources in just that region, and then in Europe they might have their own policies, right, or their own regulation that you need to adjust for. As nothing applies to Asia or Africa, right? So that's why we have that option of AWS config. And she also mentioned open policy access, right? So this is an open source alternative, and you can use it with your CI/CD tools, like Terraform and whatever CI/CD pipelines that you use. Right. So then one distinction among these
Yes, I
two,
think I'm back.
you're back. Okay, nice.
Yeah, thank you so much for holding the fort. That was
All
very
right,
wonderful.
thank you.
Okay, so let me just share my screen. I was trying to get the, what is it called? I was trying to get the config thing to complete it, but for the want of time, let me just go to how open policy access or how open policy agent works. And if we still have time, I may just come back to round up the AWS config thing. So let me share my screen to we go playground. Okay, so like I said, open policy agent as a tool, it is like studying Terraform, how you know how Terraform is. So that is how it is, like it is something that you have to become an expert of. But for the one of this demo, we are going to be using this playground openpolicyagent.org. So this would help us to understand how the solution or how the process works at a high level. So this playground is where we apply our policy. For instance, so let's take it that this is our CI/CD pipeline where you make your policy, you add it, so that when people want to make git make pull request into the main branch that eventually would go into from the GitHub to the CI/CD pipeline and deploy it on AWS or on your infrastructure, for instance, they won't be able to do it. So let's take this playground as the CI/CD pipeline. I'm going to delete it. So now I think I have a code written here on the Rigo. This is the Rigo query language, not programming language. I think this is what it's going to query. So based on this, for instance, the input is public read. What I mean is that every S3 bucket that has public access, or every S3 bucket that has access control list as public read. What this policy is going to do is that it is going to deny it, and it's going to deny it with this message: S3 buckets must not allow public read access control lists. As simple as that. So here, this is where we're going to put our inputs. Let me fetch it. So this is a Terraform code, but I didn't want us to start deploying Terraform, so I have to just get this little snapshot. So this is on JSON. And by the way, this is not how most Terraform codes are. They are on HashiCorp configuration language, but this is the JSON part of a Terraform deployment or Terraform configuration. And this is the resource AWS bucket and name my demo bucket. That is the name of the bucket, and it has access control list as public read. So right now, if we try to evaluate this, so let me take for instance, I want to deploy or apply a Terraform configuration or Terraform deployment that has an access control list of an S3 bucket as public read. What is going to happen right here is that if I try to evaluate this, you're going to get a result. Okay, so I think there is an error, failed to evaluate policy, error passing policy to approval. If keyword is required, rule body contains keyword. Let me have a look at it. Coming. Mm, there is an error. So what is supposed to happen is that we are supposed to see the results of this application here. So resource type S3 bucket, name, demo, access control public, equal to.
Mm,
I think everything checks out for me. I don't know what the problem might be right now, but it's something I'll have to have a look at.
Okay, I've not really written much Terraform, but I think maybe in line theory, just before that include or resource, and maybe there should be an if they're looking at the error output.
No, I'm not sure I can. Okay, yeah, if keyword is required before the role body. Come on, let me check my document again. Um, hmm, so let me change this to private first. Hmm, stop sharing. Okay, that works. Sorry, it's one of the things we see. It used to work. It used to work just easily, but for some reasons I don't know what is going on right now.
Mm.
So wait, field to policy error, passing to
Demo day
error,
is always
conformity.
fun.
Yeah,
Because
we go past error if keyword is required before rule body. You usually don't use if keywords on the rule. We don't use keywords on the rule, but then policy 3, line 3, deny message. Regular pass error contains keyword is required for partial set rules. Hmm, public read. Sorry guys, at this point in time I can't validate what the issue is, but I have to go and look at it again. But if you're following on the demo, you already know what we've done. You can just maybe, since this is openpolicyagent.org, you can try to make the rule. If it gives you the same error, you can just do a little bit of debugging for the want of time and not to keep us here further than suppose. Let me just end this here so we don't stay here more than 1 hour 30 minutes. So I'm sorry that it didn't work. It's worked for me. I don't know why it is not working right
it's
now.
yeah, because even when Meta was demoing their Meta glasses, they had similar issues. So yeah, it's all
Yeah.
good. So thank you very much, Diogo, for this session. Right, and I didn't hit on myself. Right, you went quite in depth on each part and how it works and how it works as a whole. So that was very nice to listen to. Right, I was wondering if we really talk for that long, but it was nice that you could go that long without taking any breaks. So next up we'll look at some questions from the chat. Right, so I'm scrolling to the top, and okay, the first one seems to be: can we change the policy after creating the buckets? So I'm assuming is that one of the SCPs or the yeah. So you can answer it. Yeah.
Okay, wait, can we change the SCP? Is it from the SCP or from the AWS config after a bucket has been created?
Okay, the person did not specify, I just said policy. Just said policy. But I'm
So
seeing
the thing is that at this point in time, I'm not sure that except if you applied an SCP that has to do with public buckets in AWS, but SCP does not scan. So what will happen is that it would apply for the buckets that will be created after the SCP had been configured. So unlike AWS config that does random scans, I don't know if you're getting what I'm saying. AWS config would just after some time it would be scanning and scanning and scanning, but SCP is just like a block. It does not move. It doesn't scan. So it
mm,
means that it is the bucket that will be created after. that is going to be denied by default, not the ones that have been created initially.
Okay, okay. So I think maybe what is asking is, so after you create the bucket, can we change the policy
Mhm.
that
Yes,
applies to that
yes,
previous
yes,
bucket?
yes, yes, you
Yeah.
can.
And okay, so I think that is from Mohammed Dawood. So if you're still here, I hope that answers your question. Then we also have a question from from William Tijesuni. So he said a question on SCP. It seems
Mm,
it does not work on IAM under OU, or does it? Because I did
SCP.
mine some time ago for the 9 tag compliance rule. Okay, so I think what he's asking is for SCP, he's asking if it works
Mhm.
under like AIM rules or permissions. Because when he
Yes,
tried it a while ago for the 9, I'm not sure it works for him.
actually,
Any,
it
like,
works. Yes. So the thing is that SCP was majorly made for identity and access management. If you go to your individual account IAM, you would see SCP there. But for IAM, I think maybe it's how the rule was applied. You know that unlike AWS config that gives you the rule that you can just apply for SCP, you have to write the rule yourself. And all you just need is, so long as the syntax, the JSON syntax is working as intended, it is not going to flag if the rule is effective or not. So what it means is that if the rule is not wrong, or if the rule does not apply to as much as it should, you won't get it, you won't see it denying things on the OU account. So I think you should just maybe try to rework the rules that you currently have set on and reapply it again on the OUs. I think it should work, but it works a lot for identity and access management.
okay, thank you very much. So that is for William to Jason. Right, so I hope that answers your question. And you can just ask or confirm in the chat if you want some more clarity or a different angle you want it answered from. Then another question from John Odo. So he says, if my startup is using only one AWS account, can I still enforce service control policies? I think
Yes. So
so
if
that
you
is
have one AWS account, you can enforce service control policies, but you have to, for you to even use AWS organization in the first place, you need more than one AWS account. It is the additional AWS account that makes it an organization, and SCP is an organization's resource. So it means that when you get to AWS organization, to enable organization, you can have to create an other AWS account, but try it. I've not used one account, SCP on one account before. So, but you can just maybe for the sake of curiosity, try and see if you can apply it on one account without creating an AWS organization. But I think you should create an AWS organization, even if it's another account. And then everybody needs an AWS organization as well, because you can't be working with your root account. So, and it doesn't charge money though. So just create it. If it doesn't work with a single account, try it with creating an extra account. That is where I 100% sure that it works.
works. All right. So thank you very much. So that's for John. Then the next question from Timothy Olubi. So I'm not sure if he's asking something from our session this evening. Right. So here's what he's saying. I have experience in AWS cloud platforms, but I want to dig down to AWS cloud security. I would love to be like you, and if possible, to have connection with your team. So I think he's asking probably how we can connect with you, and
Yeah.
get on that
So
path
if
that you are currently
since
on.
since he's joining from LinkedIn, I think you should easily find me from the LinkedIn events. I shared the post. You can look at people who reposted the events. I shared the post, so you can just send me a message on LinkedIn and then we'll move from there.
Yeah. Okay, all right. Thank you very much. I think those are all of our questions. So I'm gonna take that. we've all understood, most not all of what Diogo shared with us today. And with that said, we'll be moving on to the next segment for today. That's an even more fun part for today's session. That's the Kahoot games, right? Um, some on Ask context, I've won Kahoot before, right? So I hope that you guys that have been listening also win today. And after the Kahoot games, the winner will get a voucher from the AWS community here, right? So I'm going to share my screen in a bit so that we can start the game. So I think if you're inside your room, you should probably go to the edge of the window so that you can get a very good network where you are. Um, Okay, so let me share my screen now. Okay, so I'm going to just start this. Okay, so for those who may not be familiar, Kahoot is a way of games, right? So what you can do is go to www.kahoot.it, right? So you just load like a page in your browser and then you enter this game pin, right? Or if you are watching from your PC, you can scan this QR code on your phone. So I'm going to wait for about 2 4 minutes for a couple of you to join in, then we can start the games. So once again, www.kahoot.it. Right, so if you have the app, just open it up and join with the game pin. Okay, so someone has joined. I'm waiting for the rest of you to join in. So, hmm. So what if I share more than vouchers today? Right? Who knows? Who knows? What if we are sharing vouchers for more than one exam? I wonder. I wonder. Or maybe you might want to give away a MacBook. I'm not saying that I'm giving away a Mac. I'm just saying what if, right? So what if? You never know. Never know. I'm still waiting for the rest of us to join. So in about 2 minutes, we'll start the game. Right? Okay, so I'm just going to give you tips, right, on how Kahoot works for first timers. So you will see the question on like you see the questions from my screen, right? So like wherever you're watching this from, be it LinkedIn or YouTube, right? Then you'd have to allow then you see the options on whatever device you're opening the Kahoot with. So if you're watching on PC and you're playing the game with your phone, right, you see the question shown on your laptop or your computer, and then you now choose your options on your phone. So that is how it works. Right? So that's like you're not shocked for the first question. So you're trying to figure out what is going on here or there. And someone asking me a question. Okay, no. I think it's okay. I think we have enough people to join to start the game. Okay, that's six. Should I still wait? Is anyone trying to join? You can just quickly mention in the chat because I'm about to start the game now. Okay. Yeah, I don't see any. I'm trying to join comment in the chat. Okay, so I'm guessing that everyone who's online has joined the game. I'm gonna give you 10 seconds, 9 seconds, 8 seconds, 7, 6, 5, 4, 3, 2, 1. Okay, so we're starting now. So, what is the primary goal of Odyssey as code? Reduce cloud cost only, replace IAM users, define and enforce policies throughput and automation, or increase its to performance. So if I see certain options as your answer, I will be very, very surprised. Okay, okay, one person got this correct. That is interesting. So it means about five of you did not attempt the question. Okay, I hope you don't have network issues. So let's see the current standings. So we have coal right at the top, only at the top. That is if you watch. So next question: which tool is primarily used to detect non-compliant resources after deployment? OPAs, AWS config, cloud formation, or route 5 tree, S tree rather. You have more answers this time around. Nice. I think most of us got this correctly. Yes, so the tool that we used for this is AWS config. The next question, so current scoreboard. We still have code at the top, then Mr. Robot second, and Adiola A third. Then just so that you are aware, right? You get more points for answering the questions faster. So if you get it correct and someone gets answered it before you, then the person will get more points than you did. So just be fast and accurate. Next question. Which AWS config manage rule can detect SSH access from 0 point? So this is just from anywhere in the internet. You know that we did a demo on this particular question. There was like a full demo on this. So you should know it's like back of your head. And, okay, just two of us got it correctly. Yes, so we use restricted SSH. I remember like it took like a minute to find it. I think only these two guys were watching when she was doing that part of the demo. Right, so let's see the current scoreboard. The code is still on the top, and we have just two more questions left. I think at the other Mr. Robot can still do a comeback. You know, if you watch football, right, or if you watch basketball, you see what Madrid or what the Knicks do in the Star Conference. So yeah, you can still have a change in the dying minutes. Next question: security group allows TCP port 22 from anywhere on the internet. Why is this considered risky? Hmm. You know what's funny, right? I think I already answered this by mistake. So yes, because I said from anywhere on the internet. So I started with the IP address on the internet, but it's being followed closely by Adiola. Okay, so let's see. Final question, final round. Now, so last question. What is the main purpose of a service control policy? What is the main purpose of a service control policy? What is the main purpose of a service control policy? 3, 2, 1. The main purpose is to set maximum permissions for AWS accounts in an organization. Mm. Okay, so next we'll see what the final scoreboard is because we just answered the last question. Okay, so in third place, who do we have? Mr. Robot. In second place, Adiola A. Okay, and in first place, uh, Mr. Cole. So well done and thanks to everyone for participating. Right, so it's good that we all learned it's not two from today's session. What is going on with my screen? Okay, right. So thank you all for joining in, and Mr. Cole, please drop your email address in the chat, so that we can reach out. Okay, no, sorry, just send an email to AWS Cloud West Africa, like on the screen. Right, please. Thank you. Okay, and that brings us to the end of today's session. I'm seeing. Okay, yeah, so I'm gonna say a very big thank you to everyone for making this session happen, right? So big thanks to the organizers of the series. Big thanks to our speaker for today, Diogo Anieku, right? So once again, she's a senior information security analyst at Digis LLC, and she's an AWS community builder. So if you would like to, follow her work and follow what she does, please feel free to reach out to her on LinkedIn, right? So I'm sure that she'll be happy to accept your connection. Right? So for those of you that want to, follow a similar career path or want to learn something similar, from the class security space, right? So you can just search for her name on LinkedIn and send her a message. Then also please feel free to join the um the community, right, on so you can just follow the AWS Classic user group community on LinkedIn, and can also reach out and also join the community on WhatsApp as well. So we'll be happy to have you here. And not to forget, we still have more of this series coming up. So this is the ninth edition. So we have one every week. So you can just follow the community on LinkedIn so that you get updates on when next and what topics we have next week. So glad to have you all join today and look forward to having you guys here again next week.